Here's a machine that will walk you through a graduate-level proof in 3 languages at 2 in the morning. Now ask it today's date. It guesses. Ask it to multiply a 7-digit number by a 5-digit one, and it doesn't calculate. It predicts what the answer probably looks like, then delivers that guess with total composure. A paper out of Meta put the contradiction in writing. Paradoxically, it said, these models struggle with basic functionality. The genius loses at arithmetic. So today, what happens the moment somebody finally hands it a calculator? Welcome back. Last region, we taught the model to look things up, and it got smarter about what it knows. But one rock has been catching our boot this whole journey. The model cannot lay a finger on the world. It will describe an email beautifully. It cannot send one. Everything it has ever done, it has done by talking. So this is Region VIII, and the premise is one sentence. What happens when you give the thing that only ever talked a pair of hands and feet? It stops being an answer machine and becomes a worker. That creature is what everybody means by AI agent. Those hands didn't sprout overnight. Wind back to early 2022, when research grew along 2 branches that pretended the other didn't exist. Branch 1 was reasoning. Google Brain's Jason Wei found that if you make a model spell out its middle thinking in words, chain of thought, it solves hard problems far better. Branch 2 was acting. OpenAI's WebGPT learned to search and click inside a text browser. And here's the problem. Reasoning spun thoughts in its own head, checked nothing, and the hallucinations went straight through. Acting never asked why it was doing any of it. A genius with no hands and a worker with no head on the same ridge, facing away from each other. Let's name the weakness precisely. For valleys, the knowledge cutoff, nothing after the day training stopped. No real-time information, today's exchange rate, this morning's news, the status of your own server. Unreliable calculation, which we just watched. And the context window, which is fixed and smaller than your problem. Now, the good part. Every one of those has a specialist sitting right next to it. Cutoff and real-time, both fixed by search. Calculation fixed by a calculator or by actually running code. The context limit fixed by external memory. The model doesn't have to be good at everything. It only has to know who to put on the job. So instead of faking knowledge it doesn't have, it asks a tool that's good at the job. That's tool use, also called function calling. Mid-sentence the model makes a call, I shouldn't be making this up, I'd better reach for a calculator, and instead of answering, it emits a request. And here's what everyone gets wrong. The model does not run the calculator. What it has is an extremely confident notepad. It writes down what it wants done. An outside program reads the note, does the work, and hands back the result. The model takes that in, we call it an observation, and keeps writing. Which is why the job of stopping a tool from doing something catastrophic stays with the human. The model is not the one holding the knife. The book's analogy is a strategist chained to a desk. Brilliant, but bolted to the chair. They don't need to know everything. They need one telephone. Call the bank for the exchange rate. Hand the math to an accountant. Send an assistant for the news. Once you see it that way, the org chart of an agent gets simple. The model is management. The tools are staff. And management's competence is not measured by how much they personally remember. It's measured by how well they delegate. Which, if you've ever worked anywhere, you already knew. Now, a sharp viewer is about to slap their knee. Isn't that what we just did with retrieval? Exactly right. Everything we built last region was one tool bolted on, search. Let the tools grow, calculator, email, database, external services, and it becomes the real thing. The ancestor here deserves a mention mostly for the name. In May 2022, AI 21 Labs published an architecture called MRKL, spelled MRKL and pronounced on purpose, exactly like the word miracle. Its claim was that the model is just a router and the real work belongs to expert modules outside it. So the idea was already fully formed, and the researchers, having had it, immediately named it after a miracle. Nobody in this field has ever been accused of underselling. We bolted on a tool. But real work almost never finishes in one call. Which brings on the famous one. The React Loop, published by Shunyu Yao and colleagues from Princeton and Google in October 2022. The name is the definition. Reasoning plus acting. One cycle turns on 3 beats. Thought. The model leaves itself a note on what to do next. Action. It calls the tool it just decided on. Observation. It reads what came back. Then straight back to thought. Still not enough, look again, or got it, I can answer. Picture a climber on an unfamiliar peak. Check the map. Take the left ridge. Climb into fog. Unfold the map and redecide. Nobody sprints to a summit in one shot. So how is that different from plain function calling? One thing, and it matters. React weighs the why first. Before reaching for a tool, it runs, is this actually the right tool here, through reasoning as a filter. Plain calling asks and answers immediately. React looks, judges, then moves. And this isn't wordplay. The paper has scores. React caught the hallucinations that pure chain of thought kept producing. On action benchmarks, it beat the previous best, methods trained with imitation learning and reinforcement learning, by 34 points and 10 points of absolute success rate. Today, essentially every agent worth using moves this way. Now, the idea that produced all of that. By Shunyu Yao's own account, the entire starting point was one question. Why don't we also enable the text agents to think? That's it. That's the sentence. The reasoning people and the acting people were playing in separate sandboxes, and the whole notion was to cram the two into one loop. A field was founded by a question short enough to fit in a text message. One correction while we're here. React did not invent tool calling. WebGPT was already doing that. What React opened up was interleaving thought between actions. Having the agent, like a person, think out loud at every step. Let's settle the definition. What's the actual difference between tossing a Model 1 question and having an agent? 3 pillars. All 3 standing, you have an agent. Missing even one, you have a clever answer machine wearing a lanyard. Planning, given a hazy goal like build me a shopping mall, it slices that goal small before doing anything. Memory, because when the loop turns a few dozen times, information piles up and the context window is finite. And tool use, the hands and feet. Take away planning and it wanders. Take away memory and it forgets the way it came. Take away tools and no matter how magnificent the plan, it can only talk about it. Agents split memory in 2, and the split is the whole trick. Working memory is short-term, what it just observed this cycle, used and thrown away. Long-term memory is where the plan lives, and reflections like, that path was blocked earlier, don't go back. And remember the failure so you don't repeat it grew into its own research line. The same group behind React published Reflection the next year. The agent reflects on its own failure, writes it into long-term memory, and feeds that into the next attempt. Which is exactly a climber jotting, this ridge is dangerous, take the detour. That's when memory stops being a storehouse and becomes a notebook that learns. Back to planning, and specifically task decomposition, because 8/10 of the magic that makes an agent look like it's figuring things out on its own comes from right here. Take build me a shopping mall. But a skilled worker slices it the instant they hear it. I'll need a product listing screen and a cart and payment bolted on and a database to hold the products, and that's decomposition. One giant lump, cut into pieces a single worker can hold. And a React loop then turns for each piece. Create the product table, thought. Call the database tool, action. Looks right, observation. That decomposition stacks in 3 layers. Strategy at the top, the one goal, summit the peak. Tactics in the middle, product list, cart, payment. Operations at the bottom, one tool call. Create one database table. That bottom cell is where a single turn of the loop revolves. Now the trap, and it catches careful people specifically. The finer you slice it, the better is false. Slice too fine, and every trivial step becomes a tool call, cost detonates, and the agent gets lost between steps. The right size is a chunk a person could handle in one stride. Marking the ridge on your map, every single meter, is not a guide. It's noise. There exists a to-do list so detailed that reading it takes longer than doing the work, and some of you have written that list. So, who asked that one question? Shunyu Yao came out of Tsinghua's gifted program, the Yao class, and went straight into a PhD at Princeton in 2019. The question he put to his advisor right after enrolling started all of this. Could a language model like GPT-2 solve text adventure games? Reinforcement learning used to crack those with millions of trial and error runs, and he flipped it. What if the agent just thinks out loud like a person? It did not shine at first. The breakthrough came during a Google internship, when he moved the same idea onto a simpler stage, Wikipedia question answering. His own lesson: build a good method first, and find the problem domain that makes it shine later. The stage was wrong. The idea was right. He then produced Tree of Thoughts, Reflection, and SWE Agent back-to-back, and in 2025, at 27, was named Chief AI Scientist at Tencent. Behind that question stood a mentor with a resume you rarely see. Karthik Narasimhan is the corresponding author of React and Yao's advisor. Before Princeton, he finished a PhD at MIT and spent 2017 and 2018 as a researcher at OpenAI, and in exactly that window, his name went onto the original GPT paper as a co-author. Then he moved to Princeton and co-authored React, Reflection, and SWE Agent. So read that lineage slowly. The hand that put GPT out into the world turned around and led the research that gives GPT hands and feet. He built the engine, shipped it, then came back years later to bolt arms onto it. And it wasn't a pivot. Since his PhD days, he'd been solving text games with reinforcement learning. A mentor's long interest and a student's fresh question met on one ridge. All right, one worker complete. Plans, remembers, reaches for tools, corrects itself. A genuinely sharp friend. So let's break it. Build me this quarter's sales report.
One line, right? No.
You decide where to pull the data from, pull it. Double-check the numbers, compare against last year, draw the charts, write it up, and route it up the approval chain. And tucked in the middle are forks. If sales dropped, add a root cause analysis. Hand that to one agent, and the first few steps go fine. Then the worker starts losing track of where it is. It forgets what it decided earlier, takes the wrong branch, and playing data analyst, designer, and copywriter at once, does every one of those jobs about 70% well. One worker can't hold every kind of expertise.
True for people.
True for AI. Here's a fact I find genuinely funny. Nearly every tool in it poured out inside a single 2-year window. LangChain, October 2022. CrewAI and AutoGen, 2023. LangGraph and MCP, 2024. And look at the first date. LangChain shipped in October 2022. ChatGPT landed in November 2022. Harrison Chase pushed LangChain to his personal GitHub as a side project while working a full-time job somewhere else. And 1 month later, the world caught fire. Everybody simultaneously decided they wanted to build something with a language model and found there were no tools, and this little weekend package became the headline name in the field overnight. The best-timed launch in recent software history was an accident committed by a guy avoiding his actual job. So, what replaces the overloaded single worker? Orchestration. The word sounds grand. The meaning is simple. Directing many steps, or many agents, along a diagram you drew in advance. Think about an actual orchestra. A violin, a cello, and a trumpet each playing well does not make music. It makes noise with good intentions. Somebody has to stand up front with a score and cue the strings here, the brass there. A single agent is one hiker, Orchestration is the climbing route and the role roster. And one clarification, because these words get welded together wrongly. Orchestration is not the same thing as multi-agent. One worker inside a flow, called several times step by step, is still orchestration, full stop. There are 3 signature approaches, and these are not a tidy taxonomy somebody invented for a textbook. They're tools built by 3 camps with genuinely different philosophies. Not a classification, a history. First, workflow. You draw the flow as a single graph in advance, steps as dots and forks as arrows. Because progress gets carried through every step, the flow holds together even when it branches and rejoins. The headline tool is LangGraph, and its whole value is predictability. A human set the forks so the AI doesn't wander off on its own. It's the boardwalk laid along a hiking trail. Low on freedom, safe, and you always know where it ends. That was deliberate. The LangChain team built LangGraph after facing early LangChain's weakness: too little control over the flow. Second, the supervisor pattern, and here the analogy fits like a glove. Instead of one all-purpose worker, you put a foreman on the site. And the foreman never swings a hammer. It looks at the work coming in and parcels it out. This to the search specialist, that to the calculation specialist, the write-up to the writer, then gathers everyone's results back. The foreman judges exactly one thing: who gets handed what. The tool for this grain is CrewAI, and its maker, Joao Moura, has a specific philosophy behind it. An agent isn't a cog following if-then rules. It's something that should carry agency and decide its own execution flow. If workflow is the walk the boardwalk school, the crew is closer to give each one a role and let them figure it out. Third, multi-agent collaboration. No foreman, workers cooperating horizontally. The representative tool is AutoGen, out of Microsoft research in the fall of 2023, and the core idea is that agents solve a problem by talking to each other. A writer and an editor passing a manuscript back and forth. So, workflow, controllability, the boardwalk, for work where a mistake is fatal. Supervisor, agency, and roles for when expertise genuinely divides. And one story about AutoGen, because it's a good one. In late 2024, the core creators, Chi Wang and Qingyun Wu, left Microsoft and founded a community-driven fork called AG2, AutoGen 2. They walked away from the tool they'd built with their own hands and set up a rival branch under an almost identical name. Remember that, because it rhymes with the last story in this lecture. Now let me kill the most expensive misconception in this region. Bolt on more agents, and it gets smarter. Usually the reverse. Add workers, and they spend most of their time talking just to hand results back and forth. Worse, when one spouts nonsense, another takes it as established fact and builds on it confidently. You end up with 2 agents nodding yes, exactly, at each other and cementing a wrong answer into place with beautiful teamwork. Congratulations! You have not built a system. You have invented a committee. And the related ranking error. Multi-agent is not advanced, and workflow is not old-fashioned. The more fatal a slip, the more the controllable workflow is correct. A boardwalk is not a worse thing than a mountain trail.
Right.
The workers are moving on their own so the human can take their hands off the wheel and go get coffee. Not a chance, and here's the precise reason. We established long ago that an AI can be confidently wrong. In a calm, clear voice it announces this is the way, and every so often it is pointing at a path that does not exist. But an agent acts. It sends a mail. It makes the payment. It deletes the files. So a wrong conviction doesn't produce a wrong paragraph you can ignore. It produces an irreversible accident, executed efficiently, with a confident summary afterward. So, human in the loop. Just before an important or dangerous action, the agent stops and asks, should I really send this email? Only after approval does it move on. And the criterion for where the gate goes is beautifully simple. Can it be undone? Pulling search results, writing a draft, making a summary, all redoable.
No gate.
External API call. Hard to undo, recommended. Payment, file deletion, deployment, mail to actual humans, cannot be undone. Mandatory every time. Think of a mountain guide. Even when the AI is leading and finding the trail flawlessly, on the stretch you can't take back once you step onto it, a single log bridge over a cliff, the guide puts a hand up. On the flats, let it run. At the cliff, set a gate. And this is not a new idea, which is the part one love. Trace it back and you land in 1940s cybernetics. The feedback loop work the mathematician Norbert Wiener formalized, which then got built into Cold War radar and missile defense. So this safety device is about 80 years old, and it just showed up to the AI era in a new outfit. Here's the twist. One of the headline features LangGraph advertises for its own runtime is exactly this. The most cutting-edge agent framework on the market found the oldest control engineering concept available and shipped it as a premium feature. Last feature of the terrain, and it starts with a piece of furniture everybody owns. The drawer. The one full of chargers. Every device had a different jack, and now there's a drawer in your home that is legally a cable graveyard, and you can't throw any of it out, because what if? For years, that drawer was exactly how AI connected to the outside world. File system, write a custom integration. Database, write a different one. Search service, another one just for that. Every source hand-wired separately, so AI kept getting trapped in information silos, unable to reach data sitting in the next room. Engineers call this the N times M problem. Pair M applications with N integration targets one by one, and worst case, you need M times N wirings. Add one tool, and the wiring doesn't grow by one. It multiplies. Then USB-C showed up and quietly ended the drawer. MCP, the Model Context Protocol, is that same move for AI. An open standard Anthropic released on November 25, 2024, connecting every external system through a single protocol. On the tool side, you fit a standard outlet, an MCP server. On the AI side sits a standard plug, the client. Same protocol both ends, so anything plugged in the agreed way just works, and N times M wirings collapse into one outlet plus one plug. Then something rare happened. The rivals adopted it. March 2025, OpenAI, officially, across its products. April 2025, Google DeepMind in Gemini. Companies do not normally build a competitor's spec into their own products. That's how badly the drawer was hurting everyone. So, how does an industry standard actually get born? Grand vision? Strategy offsite?
No.
July 2024. David Soria Parra, an engineer at Anthropic, was tinkering with internal developer tools and getting steadily more annoyed. Claude Desktop was impressive, but there was no way to extend it. So he sat there copy-pasting between two windows, over and over, like a man moving water with a spoon. He was already working on the language server protocol, the standard for code editor integration, so he connected the two pieces and let the idea cook for a few weeks. Not a flash of genius.
A slow steep.
6 weeks to the first working integration. And at an internal hackathon before launch, one team ran a 3D printer off an MCP server, proving that an abstract protocol could reach out and drive a physical hunk of metal. The other name on it is Justin Spahr-Summers, and his contribution is the one undervalued in every origin story ever told. His share of MCP was the turn the idea into a product stage, making the prototype actually run, growing the internal conviction that this could be a big deal, and moving the organization to back it. He filled, by hand, the distance between a good idea and a surviving standard. That distance is where almost every good idea dies. And then the most dramatic scene in the MCP story, which isn't in the technology at all. In December 2025, Anthropic donated the spec it created to a foundation under the Linux Foundation, one it co-founded together with its competitors, OpenAI and Block. Which is exactly the lesson the history of the web keeps proving. For a standard to truly become a standard, its maker has to let go of owning it. So, how do you put all this to work on Monday morning? For moves, all short. 1. Break complex work into steps out loud. First the product list screen, then the cart, payment last, and stop and show me at the end of each step. Better yet, make the agent surface its own decomposition first, which blocks the accident where it charges confidently in the wrong direction for an hour. 2. Force the observation. After you write the code, actually run it and report the result. 3. Hammer a human gate into anything irreversible. Before you delete a file or send mail outside, stop and get my OK. 4. Attach what you need as MCP servers. And the map itself. We opened with a genius that couldn't multiply. Tool use fixed it. The model emits a request, an outside program does the work, and the model never executes anything itself. The React loop made it look and judge and correct instead of barreling at the summit. 3 pillars hold it up. Planning draws the path, memory recalls the path walked, tools take the step. And task decomposition is where most of the apparent intelligence lives. Cut the job into strides a person could take, not meters on a map. Then we became the foreman. Orchestration is designing work as a flow, and it doesn't require multiple agents. Add agents only when the work genuinely branches, or you've built a committee that agrees with itself. Put the human gate exactly where actions can't be undone. And plug your tools in through one standard outlet instead of hand-wiring a drawer full of cables. One sentence to carry out of here. An agent's power isn't how much it knows, it's what it's allowed to touch. Everything in this lecture comes from Region VIII of a book called the AI Development Atlas. It's built on one idea. In the age of AI, the person who commands the tool isn't the one who memorized the most syntax, it's the one who knows the terrain, who can point at the map and say precisely, the problem is right here. 10 regions from the Frontend all the way through AI transformation, each drawn as terrain you can actually walk. $24, EPUB plus a 561-page PDF. If this road made sense to you, the full atlas is available right now, and the link is in the description below. Next time we put the map down and start walking. Everything so far has been about learning the terrain. From here on, it's about taking this map in hand and setting out on foot. Region 9, Vibe Coding in Practice. If this was useful, subscribe and I'll see you on the next trail. DK Corporation know the terrain. Command the tools.